Okay, next we're going to talk about the Pythagorean theorem. What happens is in a right triangle. Now, a right triangle is one of those triangles with this 90-degree angle over here in the corner. So you've got these two lines that are perpendicular. We call those the legs, A and B. It doesn't matter which one you call A and which one you call B, as long as you remember that those are the legs. And then this guy over here is called the hypotenuse. He's always the longest side, and we always call him C. So A and B, it doesn't matter which side you call A and B. All that matters is that the hypotenuse, the longest side, is called C. And then here's what the Pythagorean theorem says. It says A squared plus B squared equals C squared. Hopefully that sounds familiar. Which basically says if you take one of the legs and square it, add it to the other leg squared, it'll always equal the hypotenuse, right? The longest side squared. And that's the formula you're going to use for these ones. And then it's all about a calculator after that. Whoever's missing, because sometimes A will be missing, B, most of the time it's C that's missing, but it could be any of them. And you just have to solve. So let's look at how to solve these. All right, this one says we've got a leg of 12. Let's call that one A. Doesn't matter. Here's another leg across the bottom. We're going to call that one B. And then this guy C is going to be your hypotenuse. See how he's the longest side? He's also the one directly across from that. It's a 90-degree angle, right? The square right there. So doing the Pythagorean theorem on this one, we've got A squared plus B squared equals C squared. That means that in place of A, we'll put 12. In place of B, we'll put 5. And then we're going to have to solve for C squared. Okay, then you calculator those. You get 169 equals C squared. Now, C squared means we've got to do the square root of both sides, which will cancel that squared. Got to do it to both sides, which simplifies this right side down to C, and then boop, 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 calculator says that's 13. So your C right here is 13, and then these guys have an M for meters afterwards. Okay, this one over here, notice how instead of giving you the two legs, the two up and down and left and right ones, now they've given you the hypotenuse. Let's just see. So now if we call this one A and this one's B, now we're trying to find A. Same formula. The only difference is now we have something to plug in for B and something to plug in for C. Okay, keep A squared as the variable. Plug in everything else. Minus 4. That will cancel that. Now we're back down to the same spot as over there. We've got A squared equals something. So to get rid of that squared, we've got a square root, which cancels the squared. And then you square root the right side. Now this left side becomes A, but the right side, there is no square root of 5. If you calculator it, there's no square root of 5. So you just have to leave it like that. We'll leave it as the square root of 5. If it simplified down, you could simplify it like this one over here. It actually gave us a value when we took the square root, but this one doesn't. All right, this one's a little bit different because now it's flipped upside down. But here's that 90-degree angle. This guy is the longest side, which means he's going to be the hypotenuse. Now it has the letter X here. It really doesn't matter. You can call it C, X, P, Q. You can call it square. All that matters is we need to find the hypotenuse. So we've got two legs here. Doesn't matter which one's A and which one's B. Using the same formula. A squared plus B squared equals C squared. See, that's going to be 48 squared plus 14 squared equals, I don't know, squared. Now 48 squared, 2,304 plus 14 squared, 196. And then we're going to add those together. It's 2,500. Of course, to get rid of the squared, you have to square root both sides. And we get that C is 50, which is, actually they called it X. Again, it really doesn't matter. What matters is that you got that X value right there. Okay, now this example right here, same idea. We've got to find this guy. We've got our two legs here. Same formula, A, B, C, right? A squared plus B squared equals C squared. Plugging in 2 and 4. Okay, calculator. 20. Do that whole square rooty thing to cancel that. Got to do both sides. Now, here's how this example is different. We got C equals the square root of 20. Now, if you plug in the square root of 20, it comes out a decimal, which means it's not perfect. But if you remember before, we had to take these and simplify them down. So we're going to break 20 up into prime numbers. 5 is prime, 4 is not. Oops. So I'll break it down further. So the square root of 20 is actually 2 times 2 times 5. Whoa. So now you look at it and you say, hey, wait a minute. There's a pair of homies. Remember breaking out of jail. One makes it out. The other one dies. And then this guy over here, the 5, he's left in jail because he had no homies. So that's the other thing you've got to do, is be able to reduce those down. And you do that by breaking everybody out of jail. Okay, there you go.